Hi. In the previous video, I showed you how to use the command function to run a training job. In this video, I'm going to show you how to build a machine learning pipeline in a couple of ways. Okay. So, machine learning pipeline is a way of defining a workflow. For instance, right? So, when you're training a machine learning model, you might be doing several steps, right? So, you might be sourcing data from one or more data sources, combining them, do some data preparation, right? And then you do feature engineering, train a model, and then you evaluate and then finally register the best model, right? So there's various steps involved, right? So and each of the steps, right? They may use, they may need a different compute needs, right? For example, if you're training a deep learning model, right, so you might need a CPU cluster to do all of your data preparation work, and then you use the GPU clusters for training the models, right? So instead of bundling everything into one single job, by using machine learning pipelines, you can break it down and then run the entire workflow. Okay. All right. So let me go to the Visual Studio Code. Okay. So just to walk you through the setup that I have for this particular video, right? So in the previous couple of videos, I showed you how to use MLflow, also the command function, and then I've used I've trained a simple classification model, right? Remember, right? So I have the data generation as well as model training in one single module, right? So what I've done is I've broken down into two steps. So I have a generate data Python module that you can see here. Okay. So and then for this, right? So I've defined several command line arguments. For example, the number of samples that I want to generate, the number of features, number of informative features, random state, and then the output file path where I would be saving this particular data as a CSV file. Okay. So again, using these parameters, I'm making use of the make classification class from the sklearn datasets, passing all of these parameters, and then generating the training data. Okay. I've also leveraged MLflow just to log the parameters, especially the command line arguments that are used to train this particular data. Okay. So, and from a setup standpoint, I also have so we know, right? So when we deployed the Azure resources, we also deployed the Azure Key Vault, right? So I created a secret called secret demo, and I'm going to print that secret value as well. Okay. So this is just to show you how you can connect to other services from within Azure. Okay. So I'll cover more on this when we actually start building a pipeline. Okay. But for now, right? So if you go to the Azure resources, so let me go to the resource group. Okay. And then if you look at the go to the access control pane here, right? So um, I have the as a user, I have the key called administrator permissions, right? Meaning I have the ability to read, write the keyword secrets, right? But if you look at the user assigned manage identity, it only has the ACR pull permissions. Okay. And then even if you go to the compute clusters, so I have two compute clusters that are running. And then for each of these clusters, I've associated the user assigned manage identity. Okay. So just to repeat, right? So this user assigned manage identity only has the ACR pull permissions. Okay. It doesn't have access to the keyword, right? But I, as a user, have access to the keyword. Okay. So that's my setup, right? So two clusters, and then um, so I've broken down this into two Python modules, right? So basically, if I run this particular Python module, right, I should be able to generate the CSV file locally. Okay. And then the other Python module also has a similar, like I have the command line arguments, for example, the input file path. Okay. the number of estimators, max step, minimum sample split that are needed to train a random forest classification model, and then a random state, right? So I'm going to parse that input file into a pandas data frame, break it down into x y arrays here, right? So numpy arrays, and then I'm making use of the train test split into to split the data into training and test data sets. Started an ML flow run, log the parameters, train a random forest classifier model, right? And then calculate the accuracy metrics using the test data set, as well as log the metrics, artifacts, and then the scikit-learn model. Okay, so this is the other Python module, right? So again, as a repeat, right? So in the previous videos, all of these were in a single Python module. Okay, so if I run the generate uh, data Python module, right? Um, I should be able to generate a CSV file with the dummy data set. So it finished running, and you can see the secret value. So I'm able to connect to the key vault using my credentials, and then I have the experiment run as well. Right. So if you go to the Azure ML workspace, if you go to jobs, you go to all jobs. Since I have not specified the ML flow experiment, it went into the default experiment, right? And then we also haven't configured the ML flow tracking server, but since I've used the Azure ML compute instance, it's already configured for me. Okay. And then if you go to the run, right? So we see all the parameters that were logged using ML flow, right? And then I should be able to run the training script as well by pointing to the CSV file. Okay. So this finished running, right? And let's go to the Azure ML workspace to see the tracking run on the ML flow. Let's click on the latest run, right? So we can see the parameters that were passed, as well as the metrics, append scores, as well as the model artifact, as well as the the confusion matrix PNG file as well. Okay. All right. So I think we were able to run this locally, right? So in the first method, right, in the first example, right, so I'll show you how to create a ML pipeline using command jobs. Okay. But before that, let's make a simple change. So let's go to the generate data Python module, right? I'll just comment this out, and then I'll make use of the Azure ML on behalf of credentials. Okay. So this is from the Azure AI ML identity module, right? So I'm just going to make use of this Azure ML on behalf of credential, from the job. Okay, so that's one change. So let me just save it and then close it. So let's go to the Python module here, right? So I have I'm importing the ML client command function, DSL output input, and then I'm also loading a few entities, environment, build context, all of this into the Python, module. So let me run this particular cell, okay, and then I'm going to create an ML client by passing the subscription ID, resource group, ML workspace name, okay, and then I've defined few variables, the prefix, environment name, the user assigned, manage identity, and then the compute cluster name, okay. Let me run this command. So basically, here I'm going to create the environment. Okay, it's like same as in previous video, right? So I'm making use of the build context, and then I have a folder here. Within this, I have a Docker file with Python 3.11.14 version, and then I have a requirement.txt file. So these are all the dependencies that you saw previously as well, right? So for training the scikit-learn model. But I've added two more Python packages here. One is the Azure ML FSPEC, because I'm going to make use of the data store to persist the CSV file that from the generate data Python module, and then I'm going to connect to the data store when I initiate the training run. Okay, and then I also have the Azure Key Vault secrets package, because I also want to show you how to connect to the Key Vault from within a job. Okay, so these are the additional libraries. Okay, so that I have. Let's go to the module again, right? So I've ran this particular cell, right? So it's going to either create or use a existing environment, right? And then I have a command function here, okay, with inputs, outputs, environment, code, and then the folder where the Python module is located, and then the command line arguments, right? So the number of samples, features, the output file path, and all that. Okay, and then I'm just specifying is deterministic as false, just for this demo, right? So just want to rerun this particular command, instead of using the artifacts. Okay, so let me run this. So if you look at it, right, so I also commented out the user identity configuration. Okay, so let me first run this, and then let me also run a job. Let's call it something, right? So let me run this job. So it takes a few minutes for the job to finish. So in the meantime, let me just show you, right? So this command function, right, takes various inputs and outputs, right? So in the previous video, I just showed you, these inputs, right? But so I've also specified the output, right? So the inputs, right? So let's go to the Azure AIML Python reference. And if you go to the command function, you can pass inputs and outputs, right? The inputs can be of input type, or it can also be like the primitive types like string, boolean, integer, and float. But for outputs, you can only use the output types, right? You can't use the primitive types for output. Okay, and then if you look, click on input or output, right? So let's click on the output here, right? um, it has to be of a particular type. Okay, so you can only use the URI folder, URI file, ML flow model, or the custom model as your type output types. And then for the output type, you need to provide the remote path where the output should be stored, and then the mode, right? So whether it should be read, write, mount, or upload, the various modes that you can choose as part of the output object. Okay, at the same time, I've also made use of few expressions, right? So if you go to the command function, right, so I've used these expressions here. Okay, as well as if you see the path, I've leveraged the default data store and name expressions as well. Okay, so this concept, like there's like client expressions and there are server expressions. Okay, so in the client expressions, right, so you can for example, the number of samples, right? So you can use this particular expression in your command line. Okay, so when the job runs, right, so it tries to decode the value on the client side. Okay, and then there are server expressions like the default data store, the job name, right? So these are the expressions that gets resolved when it actually runs the job. Okay, so these are like the server side expressions. Okay, so that's what I've leveraged here to store the output file, and then these are the input, these are the client expressions that I've used to make use of the input parameters. Okay, so let's go to the Azure ML. Let's go to jobs. Let's go to the experiment. You see, right? So the job has failed, and then if you look at the logs, right? So basically, it's not able to get the token, right? So the reason, right? So even though like we have configured the user assigned managed identity to the compute cluster, right? So it's not able to connect to the key vault, right? But it is able to connect to the container registry, right? Again, the reason being, we have provided the ACR pool permissions to the user assigned managed identity, but not the key vault permissions, right? So the way the compute cluster works is, whenever you initiate a run, right? So there's the default managed identity, which could be a system assigned managed identity of the compute cluster or the first user assigned managed identity. Okay, so the system uses this identity to set up the user storage mounts, container registry, and data stores. That's it, right? So that's the job of the identity associated with the Azure ML workspace. I mean, if you can still leverage the user assigned, like the managed identity within your job as well. Okay, but you also have options to use your user identity as well. Okay, so if you want to leverage the same managed identity, you can do that. This is just a sample code, but in my example, right, so I'm not given the user assigned managed identity access to the keyword. So I have access to, I've provided myself access to the keyword. Okay, so let me uncomment this and let me run this particular command job again, and then see. Okay, let's go to the Azure ML workspace, and we see this particular job ran fine, right? So it leveraged my permissions, right, my credentials to connect to the key vault and then pull the secret value, right? So you can also configure again manage identity as well, right? So you need to pass the client ID, and that is what is going to be used inside the job. Okay, so just want to cover this. Let me just comment this out again. Okay, I've also defined another command job here, right? So this time I'm going to run the train.py module, again, passing the inputs. So if you look at it, right, so I've, passed the input file path. So this is the input object type in the URI file and the file path. Okay. And then mode is download. Okay. And the other parameters that's required for the scikit, like the random forest classifier model. Okay, so let me run this. Okay, so now I've these two command jobs created, right? So I said at the beginning, right? So I'm going to show you two ways to create a pipeline, right? So this is the first way, right? So I've created two command jobs, and then I'm going to use this DSL dot pipeline decorator to actually build a pipeline. Okay, so I'm going to create a function. Okay, and then I'm going to decorate with this dsl.pipeline. So DSL is from the Azure AML module here. Okay, and then if we look at it, right, so I have all the inputs that are required. For example, the number of samples. These are all things that are required for generating the data, and I have these parameters for model training. Okay, and then within this function I have created a prepared data node. Okay, basically I'm referencing the command job data function that was defined above. Okay, and then I'm passing the inputs to this command job data. I'm giving it a display name, and then I also have the command job train function. And then if you look at it, right, so the input file path is using the output file path value, right? So this is how the training step is going to use the data from the prepared data step. Okay, that's how these steps are connected, and then the other parameters as well that are being passed. Okay, so let me just run this. Okay, and then I'm going to create the pipeline job by passing the required values to this particular pipeline job. And then here I'm going to specify the identity that I want to use. So I'm going to use the user identity configuration, right? Because one of the steps, right, which is the prepare data node, requires an identity to connect to the key vault, right? Since I'm going to run this with my credentials, right, I'm using the user identity configuration. Okay, if you want, right, so you can also specify a different compute cluster, like what I was saying, right? So you can define multiple pipeline steps, and then you can use different compute clusters as well for each of those nodes. So you can do that. Okay, so you can just specify a different compute. Okay, uh, if you don't specify it, it's going to use the default compute cluster that the pipeline would use. That's what I'm specifying here. I'm going to use a compute cluster, and then I'm going to submit this pipeline job. Okay, so let me just run this. Okay, let's go to the Azure ML workspace. So the pipeline finished running, right? So if you look at the job type, it says pipeline, and then each of those nodes, right? You can see it as a pipeline step. Okay, so if we click on the pipeline again, right? So you should be able to see those two nodes, and these are connected because we said the output file path as an input file path in the next step. Okay, you can also look at the parameters, okay, for each of these steps. At the same time, right, so if you click on resubmit, right, so you should be able to see all the inputs, right? So these are all the inputs that we have configured here, right? So the number of samples and then the all of this, right? So is what you see here as inputs to this particular pipeline. Okay. All right. So in this example, right? So we have created two command jobs, okay, and then we made use of those command jobs to create the ML pipeline by using the DSL dot pipeline decorator, right? And then we have connected these two steps by using the input and output file path, right? And then we also use the user identity configuration. Okay. All right. So in the next example, I'm going to show you how to build the same machine learning pipeline, but it would do the hyperparameter tuning. Okay. All right. So before that, right? So I'm in the even the hyperparameter tuning run would use the same data generation, right? So instead of me hard coding the same, like redefining the same command job, right? I want to create an object that can be reused across the pipelines. Okay, so that's where a component comes into the picture. So component is a type of an asset, is an asset again, okay, within Azure ML workspace that you can create, which can be so basically once you create a component, it can be used across different machine learning pipelines. Okay, so again, this is the same code like in the previous module, but this time I'm making use of this command component class to create the command component. Okay, so if you look at it, right, so I have the same generate data Python module with all the command line arguments, inputs and outputs. I'm giving a version number here again just for but you can also auto generate this particular version as well. Okay, so let me just, and then I'm also going to use the components operations to create this particular command component and register that within the Azure ML workspace. Okay, so there are you can also use YAML file to define the component, but in this example I'm just using the Python SDK. Okay, all right, so let's okay, let's go to the Azure ML workspace, and then if we go to the components, so this is in the asset section, you see the sklearn classification data generator, right? So this is what we have done, right? So, and even if you look at the code, right, you should be able to see the code that is tied to this particular component. Okay, so now that we have the component, right, so we can use that in the pipeline. Okay, so that's what I'm going to show you in the next example. So I have another Python module defined. Okay, this time I'm going to do the hyperparameter tuning. Okay, the same dependencies. I also have the choice the search space parameter, right? So that I'm going to use as well. Okay, and then I'm going to use the ml client.components to get that particular component, which is the data component. Okay, this is the command job that you saw in the other module, right? So which does the training, right? And then again, I'm going to use the dsl.pipeline decorator to this and create a function, right? So same as in the other module, right? Instead of using the command job function, I'm going to use the data component and then pass the required inputs to this particular component, give it a display name. I also have the command job train, right? So this is, I'm just connecting this particular node with the previous node using the file path. Okay, I'm hard coding the estimators, max depth, these parameters, but you can also make it more dynamic. And then I'm going to create a sweep job for the hyperparameter tuning run. Okay, okay, all right, and then I'm going to create the pipeline job, pass the user identity configuration, and then trigger the hyperparameter tuning run. Okay, and finally if you look at it, right, so I'm also going to create another component. So component, uh, you can also register a pipeline as a component. Okay, so the same function that we have defined, right, we can also register that as the pipeline component. Okay, so let me just first run this. It takes a few minutes for the job to finish. Okay, so again, I'm passing the maximum concurrent trials as 3, right? So it's going to take some time for the run to finish. So in the meantime, right, so let's go to the Azure AML documentation. And if you go to the DSL, right, so basically you use this particular decorator to create the pipeline job. Okay, so basically like what you see in the documentation, right, so you decorate it with at pipeline, and then provide your components, and then you connect those components if there's dependencies between them, and then you create a pipeline job, and then you just submit the pipeline job. Okay, and if you go to the pipeline job, you can provide the experiment name. You can also provide the identity, which is what I'm doing, right? So I'm going to provide the user identity. There's also settings that you can provide, like the pipeline job settings. You can specify the default compute that you want to use, the default data store, and all that, right? So like I said, right, so if you want to use, if you don't specify a compute for your particular component or particular the node within the pipeline, it's going to use the default compute. But you can also specify the type of compute that you want to use for that step. Okay, as well as, right, so let's go to the command component. You go to the command component, right, so this is the command component, right? So uh, like you can also provide the instance count even for the command function, right? You can specify the number of instances that you want to use on the compute cluster, right? So you can do that. Okay, so this is what can do at the same time, right? So you can also register this pipeline as a component as well. Okay, let's go to the diagram, right? So what we did in this particular video is, right, so we created two um, command jobs, right? Prepare data and model training. So these are the command jobs, right? So there is a, we also connected to the key vault and printed the secret value, right? So that's what we did. And then once this pipeline finished running, right, so we register the command component, like, so we registered this particular as a command component, right? And then we built another pipeline, and this time we have used the command job component as a first node, and then the hyperparameter tuning as a command job, and built a pipeline. And then finally, right, so we registered this pipeline, particular pipeline component, right? So if we go to the Azure ML workspace components, right, you also see the model training pipeline. So this is the pipeline component that we register, and you can see those two nodes associated with this particular pipeline component. Okay, you can also, if any job references this particular component, right, you should also be able to see the job that's using this particular component. Okay, a few things to keep in mind, right? So the identity that is associated with the compute cluster, right, where which the job runs, right? So it is going to be used to set up the data store and connect to the ACR to build the environment required for the job to run, right? So that's the initial setup. So just make sure that the user assigned managed identity has the required permissions. Okay, and you can also configure the identity that you want to use inside the job, right? So as I was saying, right, so you can use the user identity configuration or even the managed identity configuration. Just make sure that you make use of those as well, right, if you have any dependencies. Okay, and one thing, right, so if you specify an identity at the pipeline level, that is what is going to be used in each of the nodes. Okay, for example, if you have the user identity configuration required in particular one of the pipeline steps, but you specify the managed identity configuration at the pipeline level, right? So the managed identity is what is going to be used, in those steps. So just make sure you keep that in mind. Okay. As I said as well, right? So you can also use different compute cluster for each of these nodes. When you define the command component or the command job, you can specify the number of instances that you need. You can also specify the compute cluster as well, right? If you don't specify any compute cluster when you define the pipeline, right, the default compute that is set at the pipeline level is what is going to be used to run your pipeline steps. Okay, let's go to the Azure ML workspace. Let's click on the experiment. So now we see that this pipeline finished running, and then you can see all the steps within this. Okay, so we're able to create both of these pipelines using the Python SDK, right? Um, and we are able to successfully run these as well. All right. Thanks for watching.